This is example 7 from lesson R.5. And now we're going to solve some of these equations involving rational fractions. The best way to do this is to find the least common denominator of all the denominators and then multiply each individual term by that least common denominator. And what that's going to do is it's going to eliminate the fractions because it will cancel out terms from the denominator of the fraction. Okay, so let's look at A. And all of my denominators are y, 3y, and 1. So it looks like my common denominator, my least common denominator, is going to need to have a 3 in it and a y. Now, y squared is not wrong. That is a common denominator. It is not the least common denominator, and we would rather use the least common denominator because it's going to save us a little bit of time and effort at the end. Also, if you don't use the least common denominator, you could wind up in a situation where you get a polynomial that it's factorable, but we don't have a way to factor it. Okay, so now that we have our least common denominator, remember I'm going to take it and I'm going to multiply each one of my individual terms times that denominator. All right, and that's going to look like this. We've got 15 divided by y times that least common denominator 3y, and remember this is over 1. This is going to be equal to 21 divided by 3y times that least common denominator 3y divided by 1 plus, this is 2 over 1, times the least common denominator 3y over 1. Okay, now let's see what happens. I have a y in the denominator that'll cancel with the y in the numerator, and I'm left with 15 times 3 over 1. Well, that's just going to give me 45. Here, I have a 3 and a 3 that will cancel, and a y that will cancel. So that's just going to leave me with 21 times 1 over 1. Well, that's just 21. Plus, and then 2 times 3y is going to give me 6y. And now I have an equation with no fractions in it, and I can solve this. So let's subtract 21 from both sides. This is going to give me 24 equal to 6y. And then when I divide by 6, it looks like my solution is going to be 4. Alright, now to do the B part, we should probably make sure all of our denominators have been factored. Now, this one's prime, this one's prime, this one's not prime, this is a quadratic. So I'm looking for things that will multiply and give me -8, that will also add together and give me a -2. And I think that's going to be a -4 and a +2, because this is -4 times +2 is -8, -4 plus 2 is -2. My variable is going to be x. Alright, so for the least common denominator, I need to be sure I have an x minus 4, and I need to be sure I have an x plus 2, and then I don't have anything new here, just the x minus 4 and the x plus 2, so it looks like that's going to be my least common denominator. Alright, so now I'm going to multiply each of my individual fractions times my least common denominator there. So that's going to give me 2x over x minus 4 times x minus 4 times x minus 2 over 1 minus 3 over x plus 2 times x minus 4 times x plus 2 over 1 equals x squared plus 14 over x minus 4 times x plus 2 times x minus 4 times x plus 2 over 1. Okay, now all we need to do is cancel out the things that will cancel. So the denominator x minus 4 will cancel with part of the numerator x minus 2. That's going to leave me with 2x times x plus 2, and all that's over 1. In our next term, the x plus 2 will cancel out with the x plus 2. That leaves me with minus 3 times x minus 4, and all of this is over 1. And then on the other side, the x minus 4 will cancel with the x minus 4, the x plus 2 will cancel with the x plus 2, and I am left with x squared plus 14, and all of this is over 1. Alright, now I have a nice quadratic equation here that has no fractions in it. So let's distribute the 2x in the parentheses. We have 2x squared plus 4x, and let's distribute the negative 3 in the parentheses. That gives me negative 3x plus 12, and this will be equal to x squared plus 14. Alright, let's combine our like terms over here. 2x squared plus x plus 12 is equal to x squared plus 14. Alright, now I have a quadratic equation. I can't solve it unless it's equal to 0, so let's move this x squared over here, and let's move this 14 over here. Notice I'm lining them up underneath their like terms. Alright, so 2x squared minus x squared, that's just x squared. I had nothing underneath the x, so that comes down, and then 12 minus 14 is negative 2, and on the other side, all of this is going to cancel and leave me with 0. So I have a quadratic equation here, and I have 4 different ways that I can solve it. And the fastest way is going to be to factor this. So if it's factorable, we should probably do that. So let's see. If there's anything we can multiply to get negative 2, that will also add together and give me positive 1. And I believe that's going to be negative 2. Nope. Sorry. Positive 2 and negative 1, not negative 2 and positive 1. Positive 2 and negative 1, because negative 1 times positive 2 is negative 2, and negative 1 plus 2 is positive 1. And then my variable is x. Alright, and now we're going to use our zero product property. So the first parentheses x minus 1 may be equal to 0, or my second parentheses x plus 2 may be the one that's equal to 0. If I add 1 to both sides, x could be positive 1, or if I subtract 2 from both sides, x could be negative 2. Now we have to be really careful with these fractions because you need to go back and check both of your answers and see if it gives you a 0 in any of the denominators. So let's see. Let's try the 1. 1 minus 4 is negative 3, we're okay. 1 plus 2, positive 3, we're okay. Alright, 1 squared is 1, minus 2 times 1, so 1 minus 2, that's negative 1, negative 1 minus 8, negative 7, we're okay. So 1 is going to be a solution to my equation. Now let's check negative 2. Negative 2 minus 4, negative 6, we're okay. Negative 2 plus 2, that's 0. We can't divide by 0, so since this solution gives me 0 in a denominator, it is not a solution to my problem. And the only solution to B is going to be 1.